the lungs are a conglomerate of small sacs called alveoli, where the air comes in at the end of the inhale and then exchanges with the blood, releases oxygen, takes carbon dioxide, and then we exhale it. At the level of the sacs is where the exchange happens. Those sacs actually imagine that they are like made of rubber band material. And their resting position would be to be collapsed and small. So the only reason why they expand and they allow air to come in is because all the package, all this network of sacs, of alveoli, in a let's say a lobe of the lung, is connected to the pleura. The pleura is the sheath that covers the lungs. And the pleura has two layers. And the inside layer is glued to all the sacs. And the outside layer is glued to the rib cage. So what happens is that between the two layers of the pleura, there is no air. There's some liquid so that it can slide, but it can only do this, the pleura. It cannot open up. So if the rib cage pulls this way, then the inner side of the pleura is going to be pulled with it, and then it's going to make the sacs open. So if you think all the lungs are here inside, when we inhale, we are pushing out the pleura, and then all those sacs open up and they suck air in. Air comes into the lungs just by a differential of pressure. By being expanded inside and pulled out, it creates a negative pressure in those sacs that sucks in the air from the atmosphere. And why this matters? Because the inhale is an active process. To inhale, you must contract muscles in order to open up those sacs. Primarily, the diaphragm is the main muscle, so it goes down as you inhale, and then it really opens. You see, the lungs are more like a triangle, so at the bottom, there's much more mass of those sacs. So by pushing down the diaphragm, you really open up all the base of the lungs. And then the muscles in between the ribs, the intercostals, and there's some muscles here called scalenes, they finish the job. They open up towards the side and the tip, right? So when I inhale, that's what's happening. All those muscles are contracting, the pleura has been expanded out, and the inner pleura goes with it, and then those rubber bands, with elastic, they expand like a balloon, air comes in, right? Great. Then what happens? We start to exhale. So the first thing we need to do in exhale, and this is a metaphor as much as it is a physiological action, we have to let go. And in our modern society, our issue is that we don't exhale. We hold in the air, right? We are contracted. So let go. When you let go, those muscles stop pushing out the lungs. They release it, and the lungs do what? They go back automatically to their natural default position. So it starts to go down, right? And then when it gets to a point where there's an equilibrium, where no air goes in or out, there you have the option of taking another breath in and then just repeat the process. So the normal, in being energy, if we don't specify how to breathe, we assume that you are just allowing this rhythm to happen naturally, right? So you active inhale, passive exhale, in and out, right? But in certain situations, we want to extend the breath. or we want to guide the breath to a particular area. So after we feel that the passive air is stopped going out, we can begin a second component of the exhale, which is an active exhale. And so what would happen there? Then other muscles kick in and do the opposite. They begin to like squeeze in the lungs further than their resting position. And the squeezing in, so if you all do with me an active exhale, you will feel that everything here is feeling like it's contracting, condensing, right? And it's essentially just if I grab the balloon and I press on it, and then I am ejecting more air out. So I can engage an active exhale 4 times more volume of air than the inhale. 5 times. You can really push a lot of air out, right? All that air normally doesn't recycle. It just tends to stay stagnant. That's why an active exhale is a very beneficial physiologically, because it renews air that is stagnant otherwise. That stagnant air means that you retain acid because you're not exhaling enough carbon dioxide, and also it means that it's an air that is less oxygenated because you haven't renewed it, so it doesn't have a higher concentration of oxygen. So that's what stagnant air means. Less oxygen for the tissue and more acidity building up in your body. So the active exhale is a way to, you cannot do active exhale all the time. You go crazy. But to engage from time to time in that is very useful.